Okay, continuing on with our cubes, we're now going to get into some for loops. So I'm going to delete these cubes. Okay, and so this is how you would do a for loop in Mel. Set an integer variable, and then you do for I equals 0, I is less than 5, increment I, so, and then in the for loop you create a polycube. So let's go ahead and execute that. And so I made 5 cubes. All right, and so now that I've got 5 cubes made, now here's another command I want to talk about. It's the ls command. And the ls command is really powerful. In fact, let's highlight it and let's look at the quick help. Okay, so this will essentially like list all sorts of things here. So a lot of things that you can do with this command. And what it's often used for is the selection. So what we're going to do is create a string array called cubes based on listing the selection. Okay. So what that means is I need to actually come in and select these items first. So I'm just going to click outside, and then you see select CL. That means select clear, to clear your selection. So now I'm going to select these cubes, and I'm going to select them one at a time in order. And now I'm going to run this string cubes LSSL. And so that gives me a string array with names of all those cubes. So we can print them, and there they are. Okay. And so the cool thing about that is I've got my cubes as a cube names as a string array. So then I can use these strings to manipulate the actual cubes. Okay, so I'm coming up with another for loop here. Okay, and here the condition is going to be so start with I equals 0, and the size command gets the length of the array. So I've got this string array of cubes. Its length is 5, so it'll iterate 5 times, and then it'll increment. Okay, and so what I'm going to do is I'm going to move each one of these cubes up 2 units. Okay, so I'm moving. So here's the x value, the y value, and the z value. So in y, I'm going to move it up 2 units times the counting value. So the first one should go up 2 units, and they should go up successively. So let's run that. So here we go. So using the string array to manipulate actual geometry. Okay. Now what I'm going to do is actually parent these cubes. Okay. So we're going to go to the parent command. And so let's click on that. Quick help. These are the strings we can use. If we go back to the documentation, parent, and we'll just look at some examples. So you parent one thing to another. It's just really simple how that works. So what I'm going to do is parent so we're not going to start at 0, we're going to start at 1. So which means we're going to go to the second cube, and we're going to parent it to I minus 1, which is going to be the first cube. And so then we'll go through successively and we'll parent each one to each other. So really important about the, starting at 1 and then parenting at the previous one. Okay, so let's run that. And there we go. So these are all parented. So on shift and click, see how they're all parented to each other. Okay. All right, so I've got these cubes and I've parented them. Now I'm going to look at a couple more commands. So I'm going to look at the group command. The group will just make, I'm going to make a group, which is just a transform. And I'm going to give it a name of each one of the cubes with an underscore GRP. And let's see what this EM stands for. So that's an empty group. So I'm naming it to whatever the value of the cubes are, and then adding a group, so making these empty groups. And then what I'm going to do is transform them. And this really isn't necessary, but I just wanted to throw this in here just to kind of show what the xform command does. So let's go to quick help on that. And so xform is something you can query. It's something that you can specify. Xform essentially will transform your elements in 3D space. Okay? So let's go ahead and run this for loop. So we're starting at 0, just going to 5 iterations and incrementing. So I'm going to make this group. Okay? And then what I'm going to do is I'm going to orient constraint and offset of 0, and then I've got weight, so weight of 1. So I'm gonna then constrain the cube groups to the cubes. And I'm also going to point constraint the cube groups to the cubes. And then here I would go in and then delete the constraint. So the whole idea of point and orient constraining them is just to put those cubes right in that location. I suppose I could use the transform command or xform as well. But let's just go ahead and so let's just do this one at a time. So first of all, I'm going to make the groups and comment out the other stuff. Okay, so here are the groups. Made each one of these groups named after each one of the cubes. And they're all there at the origin. And we'll just run these 2 lines now. Okay, so what I've done there is constrained each one of these empty groups, both with a point and orient constraint. So these empty group transforms, they're now associated with each cube. Okay. And then if we comment these out, and now let's just run the last line, which is just going to delete the constraints. Okay, let's run that. Okay, so the constraints are all gone, but the positions of the cubes are in place. So they would match their both position and orientation. And I suppose you could do a parent constraint in just one fell swoop. Okay, so now let's uncomment all of them, and let's just run through and do the whole thing again. So I'm going to get rid of the groups, and I'm going to rename the groups, or recreate the groups, and point and orient constrain them to the cubes, and then delete the constraints. So that's doing that in a for loop. Okay. So, that's going to work for that. I'll see you in the next video.